All right, so we want to do word problems involving the law of sine. So here we got a problem. We got number 4. It's the first word problem, but number 4 in this series on law of sines. A spy balloon is spotted by 2 observers who are 1,000 meters apart. We got 2 observers that are 1,000 meters apart. As the balloon passes over the line joining them, that's up in the air, each observer takes a sighting of the elevation of the balloon 2 meters above the ground as per the diagram below. What is the balloon's altitude? Okay, so you've got an observer on the left. We have an observer on the right. They're both 2 meters tall. The observer on the left gets an angle of elevation of 50 degrees. Angle on the right, the angle of elevation on the right from the right observer is 25 degrees. What's the altitude h? So what I'm going to do, I'm going to name this A, B, C, and ultimately we want to find h, right? Let's name this height of the triangle y here. Remember, underneath y, we got 2, right? 2 meters. So first things first, I'm going to find, so I know B, I know C, I got those angles at 50 degrees and 25 degrees respectively. Let's find A. So to find A, I'm going to take A plus 50 plus 25, that's going to be equal to 180. There's A plus, let's see, 50 plus 25 is 75. It's equal to 180, so A is going to be 180 minus 75. A is going to be 105. We've got 105 degrees here. So, let's say I want to find, say little c here. Let's find little c. Excuse me. I'm going to find little c. So to find little c, what I would do, I can use the law of sines. I could say the sine of big A, 105, over little a, 1,000, equals the sine of big C, 25 degrees, over little c. And cross multiply, I get little c is, take the 1,000 up on the right and the sine of 105 down on the right, so I get 1,000 sine of 25 degrees divided by the sine of 105. So in my calculator that goes to estimate little c, 1,000 times sine of 25 divided by sine of 105. It's going to give me 437.53, a length approximately. That's basically the distance from observer B to the spy balloon A, his direct distance, going from that diagonal right there. That's 437.53 approximately. So let's say I wanted to find y now. That's the height of that triangle there on the left. So I can use right triangle trigonometry. I can say the sine of 50 is y over c, right? The sine of 50 equals y over the hypotenuse, which is c, 437.53. So I bring the 437.53 up on the left, and I get 437.53 times the sine of 50 is approximately the y. I'll just say is equal to y. So 437.53 times the sine of 50, 335.17. So we got y here, 335.715. If I want to find h, that's what I'm interested in finding, right? H, this distance from here to here, I have to take y plus 2. H is y plus 2. So 335.17 plus 2, 337.17, and this is meters, right? Final answer, put the units meters. All right, so that's how high the balloon is up in the air. That's its altitude. It's the spy balloon problem. Famous problem. Here's another problem. Number 5. An observer takes 2 sightings of the peak of a mountain. meters apart. So he's taken 2 sightings. Each sighting is, one sighting is 300 meters from the other sighting. Within a direct line of the mountain. Period. The first measurement gives an angle of elevation of 36 degrees, and the second gives an angle of elevation of 28 degrees. Period. If the sighting device is 2 meters high, what is the height of the mountain? So here's the diagram that you get. So you get a mountain, and you get a dude here. It's 2 meters high. So you get that he has 2 sightings. One, and then a second one here. 2. Try that again. 2. So the first sighting was 36 degrees, and the second sighting was 28 degrees. And the difference in these sightings was 300 meters apart. So what do we want? We want the entire height of the mountain. Okay, so what I'm going to do, I'm going to name this height of the triangle. So we got some triangles here. We're going to call this height y. And here, that's going to be additional 2. So what do I want to do? I want to do some labels. I want to call this point, well, let's draw some of our triangles. Focus on this triangle right here, where I have a 28-degree angle here. I'm going to call that B. Up here in the upper right, I'm going to call that A, and right here, I'm going to call this one C. Now, how much is C? Well, we know here to the right of C, we have a 36-degree angle. So if we think about C, C is going to be supplementary to 36. So to find C, so C is like right here. So if I'm finding C right here, I'm going to take 36 plus C to get 180. So C is going to be 180 minus 36. What is that? 54, no, sorry. 144, I believe. So yeah. C is 144. That's this angle right here. Okay. So if I wanted to find A, could I find big A? Yeah. Right, I know that they all add up to 180, so I got 28 plus 144 plus A. So 180. If I add up 28 plus 144, that's going to give me 172, plus A equals 180. So A is going to be 180 minus 172. A is going to be, let's see, 8 degrees. Okay, so we got big A, big B, big C. What else do I want to find? Well, I know the distance along the bottom here to here, that's 300. Let's find little c right here. If I can find that, then eventually I'll be able to find big Y. Big Y. Big Y ends up going this way, right? First, we're going to find little c. Little c. So I use my law of sines here for little c. I'm going to have that the... Think about that for a second. Okay, so I can do sine of big A, 8 degrees, over little a, 300, equals the sine of big C, 144 degrees, over little c. Do our cross multiplication sort of thing. I'm going to bring little c up here on the left. Sine 8 underneath on the right, 300 up on the right. So we're going to get c is 300 sine of 144 over the sine of 8. So approximating that to 2 decimal places. In my calculator, I got 300 times the sine of 144 divided by the sine of 8. Give me little c is about 100, so 1,267.02. 1,267.02. So now I'm going to find a little y. So little y is going to be the sine of 28 equals little y over c, 1,267.02. Right. Sine of 28 is the opposite over the hypotenuse, y over that. So I'm going to bring 1,267.02. Up on the left, I'm going to get 1,267.02. Sine of 28 is little y. So little y is approximately, let's see, 1,267.02 times the sine of 28. I got about 594.83. That's little y. What are we after? We're after the h here, right? This h right here. So how do we do that? We take y plus the height of the man, 2. Y plus 2. So h, find the height of the mountain, y plus 2. So 594.83 plus 2. Height of the mountain is 596.83 meters. That's the height of our mountain. All right, so there we are.